This training will cover how to use the drone-amplified IGNIS 2 unmanned aerial ignition system. By the end of the presentation, and with a little practice, you should hopefully feel comfortable going out and using this tool to perform burns safer, easier, and faster than ever before. Here is a quick look at a system overview. The upper portion of the payload is called the hopper and holds the ignition spheres as well as houses the electronics, sensors, and actuators. The lower portion is called the dropper and handles the puncturing and dropping of the spheres. The overall system size is shown on the right if you need this for reporting or documentation. This picture is available in the manual as well. The system weighs 2 kilograms empty, 4 kilograms fully loaded, and is powered from a 2-cell LiPo battery. The manual contains a comprehensive explanation of how to use IGNIS. The table of contents is linked when viewed electronically, so simply clicking on the section you want will direct you to that section with a click. Section 1 of the manual is a quick start guide that contains a system overview, size and weight specs, battery info, safety systems, an overview of the Android app, info on the control bar switch layout, LED status codes, explanations of all possible error messages that could appear in the app, notes on environmental limitations, the specs on the required ignition spheres and antifreeze, a description on how to set up the antifreeze refilling station, notes on storage and transport, and a section on possible support equipment that may be useful for operations. After this, the manual continues on the detailed setup and operation of IGNIS. The manual is long, we know, but don't be intimidated. IGNIS is simple and intuitive, and the manual is long because we wanted to provide a comprehensive resource that can answer any question about the operation of IGNIS. The IGNIS app contains a number of configurable settings that allow it to be customized according to user preference or mission requirements. Start by opening the app to configure some initial settings. From the home screen of the app, select Settings in the lower left, which will open a list of options. The system of units that information will be displayed in can be configured by preference. The airspace indicator altitude will provide a visual representation of the upper operating altitude allowed by regulations in the mission planning interface. The low altitude warning provides another visual representation in the mission planning interface to help stay above obstruction in the intended flight area. Set this to the estimated tree height. The next slide explains these more. This is the altitude visualization interface used when planning an autonomous flight. The airspace indicator is the light blue portion, and the upper limit, 400 feet here, is the airspace indicator altitude just set in the app settings menu. Similarly, the low altitude warning is the green zigzag area near the bottom that represents trees and other ground obstructions. The upper limit of this is 85 feet, which was just set in the app settings menu. Setting these two limits as accurately as possible helps plan missions that are acceptable according to regulations and help reduce the chances of crashing into obstruction. To import a georeference PDF or KML, click on the Map Overlays button, then select Add Overlay File. If the overlay was downloaded from the internet or email, it will likely be in the Downloads folder. Select the overlay file and it will take a few moments to load. Once loaded, the overlay can be viewed or deleted. Check to make sure the file aligns with the map in the correct orientation and location. Tapping on the overlay toggles the visibility. Press the back button on the tablet to return to the Overlays Manager menu, and then back again to return to the home screen. Downloading maps provides high-resolution satellite imagery even after leaving internet service or cell coverage. Click Download Maps and select New Offline Region. Use 2 fingers to zoom and scroll around the map to find the operating area. The KML PDF icon in the upper left allows displaying overlays previously imported to aid in locating the intended area. This is especially useful in landscapes with few distinguishing features. Continue to zoom until icons pop up in the lower right to download standard definition imagery of larger areas and high definition imagery of smaller regions. Click either SD or HD and the area will begin downloading. The region can be renamed to something more useful than the GPS coordinates. Click Save Changes to accept the new name. IGNIS 2 includes a refill station to quickly replenish the antifreeze reservoir between flights. Begin by dropping the tube with the pickup clunk into the jug of antifreeze. Tighten the cap onto the jug by rotating clockwise. Next, snap the hand pump mount on the cap with the red marked barb on the pump towards the top. Then secure the back of the pump mount to the jug handle with a 6-inch zip tie. Connect the red marked tube to the red marked barb on the pump by pressing the tube firmly on. Connect the final loose tube to the lower barb on the pump. In order to function properly, the fill coupler must be gripped with the thumb in the depression and the protrusion on the bottom of the fill coupler splitting the forefinger and middle finger. The fill coupler stores on the front of the pump mount by pressing onto the integrated barbs. Setting up IGNIS includes a pre-flight check and some system configuration. Begin by removing IGNIS from the shipping case and setting it upside down. Check the needle assemblies to ensure the needles are clear of any clogs and the assemblies are undamaged. Check the two hatches to ensure they are in the closed position. They are closed when the protruding arm sticks out into the middle of the chutes and open when the arm is swept forward to allow spheres to drop through. Next, check that the magnets on the protruding cylinders on the slipper block are secure and undamaged. A close inspection shows the magnets stick out slightly from the aluminum. Align the dropper on the hopper and secure it in place. Start by aligning the wishbone on the slipper block with the drive arm on the puncture actuator. Once everything is aligned, push the emergency release lock on side A and B back to lock the dropper in place. Check the dual lock on the battery to make sure it is secure and undamaged, then press it firmly on the hopper. It should click when locked. Loosen the thumb screws to prepare to mount the payload. The reservoir goes toward the back of the aircraft, where the large square status LED is. Clip the mounting lugs onto the payload rails, making sure not to pinch any wires. Tighten thumb screws and plug in the IGNIS connector. Power IGNIS by plugging in the battery to the power plug. The slipper block should move slowly back and forth to the limits of its motion towards side A and B as it boots up and runs through a self-check. A series of beeps will be emitted, and the status LED at the back will indicate if the boot-up calibration process was successful. Red is in error state, and green is ready state. Open the IGNIS app and select IGNIS Setup. Select Bluetooth settings to connect to IGNIS for the first time. Wait until the tablet recognizes the Bluetooth signal coming from IGNIS and select it. If the tablet asks for a passkey, enter 1234. Otherwise, just select OK when prompted and the tablet auto pairs. Tap the tablet back button to return to the IGNIS app and select the Bluetooth address just paired with. The information on the top right should begin populating in a few moments with the status feedback from IGNIS with battery voltage and injection amount. The injection amount is adjustable by selecting Inject minus or plus to change by 0.1 milliliter increments. The default is 0.4 milliliters and works across a wide range of temperatures. The next step in preparing IGNIS for a mission is filling the reservoir with antifreeze and purging air out of the tubes to the needles. Start by moving the fill coupler over so the fill line is uncapped. Prime the hand pump by quickly cranking the handle clockwise until antifreeze reaches the pump. Connect the fill coupler to the reservoir, remembering to grip the coupler correctly to ensure proper operation. Continue cranking the pump handle clockwise until the reservoir is full. Any overfill will be returned to the antifreeze jug through the vent line. Remove the coupler and store it. Next, hold the center button on IGNIS status LED until the pumps begin to run. Repeat this until antifreeze squirts out the needles, indicating that all air has been purged from the lines. Install the needles in the dropper by inserting the assembly, pressing in on the black knob, rotating clockwise, then pulling out on the knob. Ensure the needle is locked by attempting to turn it counterclockwise and pulling straight out. Prepare the handheld remote controller for operation by first checking to ensure it hasn't sustained any damage during transport or handling. Check the charge level by a single quick press on the power button. Expand the tablet holder by pressing the button on the side. Secure the tablet by squeezing the tablet holder down. Next, connect the USB cable to the back of the controller and then to the tablet. Check the tablet to ensure it is free of damage and that it has sufficient battery level. Make sure mode F is selected on the controller. Finally, ensure that the gray plug connecting the control switch bar is plugged in securely. The switch control bar functionality is mapped out as shown here. The right-hand side of the control bar is used to control third-party cameras, so if a DJI camera is being used, these switches are not utilized. The two rotary knobs on the left can be used to trigger an emergency release of the dropper in the event of a hang fire. The knob should normally be turned fully counterclockwise. Turning both knobs clockwise triggers the emergency release. This feature will be explained more in just a moment. The 3-position switch next to the knobs is the master arm-disarm switch. Up towards the operator is armed, down and away is disarmed. The momentary switch closest to the center is unused. The final line of defense in the event of an onboard fire is an emergency release mechanism that can be remotely triggered. The video shows what it looks like when an emergency release is triggered, either by rotating the two knobs on the remote controller fully clockwise within 2 seconds of each other, or by triggering an emergency release from within the app. The dropper hangs at a safe distance from the steel-reinforced tubes to allow the stuck sphere to burn out without propagating the fire to the rest of the payload. Once the sphere has burned itself out, return to the launch site, clean out any melted plastic, remount the dropper, and continue operations. Begin the aircraft pre-flight inspection by examining each battery for any signs of damage or age. Look for cracks in the plastic, signs of being dropped, and punctures or bulges in the battery. Check the charge level by a single short press on the power button, and also check that each battery has the same charge level. Lock the camera mount in place and lock the camera to the mount. After mounting, ensure that the camera can rotate freely without hitting IGNIS. Carry the aircraft to a launch point clear of obstacles or people. Insert a set of 6 batteries until they click, making sure to not damage the electrical contacts. Raise the GPS antennas until they lock straight up. Check the arrow on the top of the GPS pucks to make sure they all point toward the nose of the aircraft. Raise and lock all 6 arms. The red lock should tactilely click and be in line with the arm when fully locked. Remove the prop socks and expand the propellers. Check the leading and trailing edge of each airfoil blade to check for large nicks or wear. Check each arm for any cracks or splintering in the carbon fiber, and likewise for each landing leg. Fill the hopper with 1-inch diameter dragon egg ignition spheres by first dropping a handful in, and then using the agitate button in the IGNIS Setup menu to fill chutes A and B. An optional step is to do some test ignitions by pressing the drop to button to test a sphere from side A and side B. These spheres should ignite well in 20 to 40 seconds if the injection amount is matched well with the ambient conditions. Be aware that the spheres can shoot up to 50 feet when they ignite, so use a bucket or grill to contain them if in a highly flammable area. Fill the hopper the rest of the way up to the desired amount. For reference, if the hopper is filled to the bottom of the aluminum stiffeners, this is approximately 400 spheres, and all the way to the top of the carbon is 450 ignition spheres. The next step is powering, connecting, and configuring remaining components. Open the IGNIS app, then power on the controller with a short press and a long hold of the power button. A series of tones will accompany the progression of LEDs lighting. The tablet will ask you what you want to connect to. Select the IGNIS app and just once for the frequency. The status at the bottom of the app will change from disconnected from controller to disconnected from drone to indicate the app is now communicating with the controller. Power up the drone with a single press and a long hold on just one of the batteries. Step back while the aircraft powers up and check the app status changes to connect to drone success. Select Drone Setup in the IGNIS app, then select the Remote Controller submenu. The left wheel function can be set to operator preference. The C1 and C2 buttons are also configurable. The recommended setup is C1 set to switch the left wheel function between pitching and panning the camera, and the C2 button is set to maximize and minimize the live video feed. The C1 and C2 buttons are located on the back of the controller as shown here. The left wheel is on the top left of the controller. Press back on the tablet to return to drone setup and make sure the lost link procedure is set to go home. Then check the go home altitude is set to a value that will clear any trees or obstructions in the event of a return home incident. Return to the home screen and select Fly to enter the main flight interface. To show an overlay, tap on the satellite icon, select Overlays, and select the overlay to display. Tap the satellite icon again to hide this menu. A geofence will prevent dropping ignition spheres outside the intended area by automatically stopping dropping if the geofence is crossed. Select the IGNIS icon on the top far right, then select the drone icon with the box around it. Now a geofence point will be created anywhere the map is tapped. Points can be deleted by selecting Undo Add Corner and replaced by selecting Redo Add Corner. The entire geofence can be deleted with a clear and replaced with an undo clear. Points can also be dragged by pressing and holding while dragging around. Manual firing involves the pilot using the sticks to fly and starting and stopping firing through the app controls. The first thing to do is set the desired drop spacing with the slider. IGNIS will automatically drop faster or slower to compensate for changing flight speed in order to drop at the specified interval. This can be adjusted on the fly if necessary. take off and fly into the burn area. Notice the IGNIS status changes when the geofence is crossed. Once you've reached the desired location to begin firing, tap the Start button and spheres will start dropping. Notice the IGNIS icon on the top right shows movement and the sphere count increasing. Locations of sphere drops will be marked by a pink and white icon on the map. Fly manually while continuing to fire, then press stop once finished. Usually you'll be using the camera to locate areas of fuel or the fire line to add depth to the line. Automated firing follows a planned mission to automatically control the flight path and firing. Tap the waypoint icon to enter the planning interface and touch points on the map to drop waypoints. Blue lines indicate transit lines that can be activated as fire lines by tapping them and turning them yellow. Tapping a yellow line deactivates it back to a transit line. Waypoints can be moved around by holding and dragging them. They can be deleted by tapping to select them and then choosing Delete. Simplify missions by deleting unnecessary waypoints in straight lines. The delete action can be reversed by selecting Undo or reversed again by selecting Redo. The entire mission can be deleted and recalled as well. Click Side View to pull up the terrain following interface. The waypoints are placed at a consistent height above ground level along the orange dotted line. Extra waypoints are added by clicking the plus signs to better follow the contours of the landscape. Waypoints can be dragged and added as necessary as dictated by the topography, and the orange dotted line can also be dragged to raise the altitude of all waypoints simultaneously. The AGL altitude is displayed above the finger dragging the line. Add waypoints as necessary to follow the land contours. Make sure to set the waypoint altitude at a height sufficient to clear any obstacles. Tap Settings to view the estimated mission duration, ignition spheres required, and calculated ignition spacing. Adjust the cruise speed with the slider and set the desired drop spacing with the next slider. The curve range changes the flight path when the drone reaches a waypoint. With zero curve range, the drone will fly straight to the waypoint, turn in place, and fly towards the next. With a large curve range, the drone will make a sweeping arc to join two flight paths and won't actually fly directly over the waypoints. The vertical flight path to the first waypoint setting can either direct the drone to fly a straight line to the first waypoint or the safer method of flying two straight lines, one vertical and the other horizontal. The waypoint mission lost link procedure should be set to end mission immediately until users are very experienced and confident in their mission planning skills. Check over the mission one last time, then hit Start. The mission will take a few moments to upload, but the status at the bottom should say Success shortly after, and then the drone will begin executing the mission. Progress can be tracked from the top view or the side view to watch the drone traverse and follow geographic contours. Once the final waypoint is reached, the drone will hover and the pilot has manual control to either fly more or return to the launch point. Additionally, another mission can be planned in flight to continue operations. After ignition operations are completed, IGNIS can be torn down in the reverse order of setup. Remove the needles by pushing the black knob in, turning counterclockwise, and pulling out. Remove the dropper by pulling the emergency release locks forward, disconnect the IGNIS cable, and remove the thumb screws. Remove IGNIS from the payload rails by rocking the back mounting lugs off, then rocking one of the front lugs off, followed by the other. Replace the thumb screws loosely for safe storage, and tuck the cable through the hopper side for protection. Flip the hopper over in preparation for draining the reservoir. Connect the fill coupler, again making sure to grip it properly. Press and hold the LED center button and IGNIS will register the fact that it is upside down, so it runs the pumps backwards now to purge all the antifreeze out of the lines and pump it back to the reservoir. Crank the hand pump counterclockwise until the reservoir is drained. Connect the cleaning syringe filled with water to the needles and hold the center LED button again to draw water out of the syringe through the pumps and tubing to flush them out. It may take a couple of times to fully flush all the antifreeze out, but eventually the water returning to the reservoir should run clear. Drain this water out of the reservoir by using the hand pump again. Then disconnect the syringe and hold the button one more time to flush all the water out of the pumps and tubing. Drain this water, then disconnect the fill coupler. Next, connect the syringe to the two check valves. Use the remaining water to flush out the check valves, and then empty the water out of the reservoir with the syringe. Store the needles on the back side of the pumps. They insert from the bottom up and hold themselves there in preparation for storage. Disconnect the battery and decouple the dual lock. Store the battery in the slot in the shipping case. IGNIS requires very little cleaning or maintenance. The vast majority of the dirtiness is confined to the dropper, which is easily separated and cleaned. Use the included cotton swabs to clean out the oval where the dropper mates with the hopper. Use some of the dry lubricant to help clean and lubricate simultaneously. Clean out the shoulder screw slots and the tracks where the slipper block bearings ride. Clean off the bearing, switching to the toothbrush and using the dry lubricant as necessary. Finally, use a cloth or paper towel to wipe off any excess lubricant or grime from the exterior of the dropper. The brush is easily cleaned by wetting it with the lubricant and scrubbing it on the cloth to return it to new looking. Use another paper cloth or towel to wipe any grime or ash off of the hopper. Usually there won't be much to do here. This hopper had a broken ignition sphere dumped in it, so it had quite a bit of potassium permanganate on the inside. Finally, after all cleaning, store IGNIS back in the case and it'll be ready to operate on the next fire. Look at the timer in the lower right and you'll see that it took less than 5 minutes for a thorough cleaning. This concludes the introductory training on IGNIS 2. Now, after a little practice, you'll be ready to perform burns safer, easier, and faster than ever before.